Good morning, everybody. First, I want to thank the colleagues from the committee to select me to talk about this, mainly also because I am not a modeler. For 25 years, I have been involved in model evaluation and applications of models to the poultry industry. And so I decided that the best way to target this and accomplish several objectives that I have that I will be discussing with you during this talk will be to talk about a model evaluation that in some way has been a part of my life. Actually, I thought that this will be, or still could be, the best way to target nutrition in many species like you guys do in ruminants and swine, but it's not the same vision that we have with most nutritionists and scientists in the poultry side. So what we are going to see is how the historical view of how modeling has been applied to poultry, the variety of models that have been developed through the years, and some of the methodologies that has been used, and the structure of the current and future models, because finally we probably will see it as a part of the NRC, and I would like that you understand how does it work and how really needs your help to keep improving. And the capabilities of the current broiler models, I don't have time to talk about much the layers, the turkeys, and the breeders, that we also have models, nutritional models for those. And we'll talk about, of course, what is nowadays, and actually my involvement now, after trying for many years to use modeling in poultry and not being successful, especially on the grants. Then it show up something that is more fancy and more appealing to everybody, that is data analytics. And now I am a professor of data analytics, not modeling. That calls more students, and that brings more grants and funding and so forth. So we'll talk about future perspectives. But the first thing that I can tell you is that even that you don't hear much about models in poultry, and people think about that there's a lot of things to do. Poultry or modeling has been in poultry nutrition for a very long time. So since 1984, about 40 years ago, we started using models in the NRC. And at that time, only 4 references were included. But in the last NRC that we have, and you will be surprised for those that don't follow poultry, in 1994, we had 300 references. And this work really started thanks to a collaboration with Israel, with the BAR, and I know that many of you sitting here have been members of this committee or panels to evaluate these grants. And now we are in the 44 or 45, I lost the track of this collaboration. And really the ideas of modeling for poultry came from Israel. And one of the calls that I have for all the Americans, and sometimes when I talk about America, it comes from Argentina to Canada to the north. It's only one continent divided in different regions. So we all are Americans. Now I am with the passport here, but we all were born in America. But unfortunately, except for the Brazilians, we really have very few scientists that have dedicated their life in the poultry side to poultry. So we will encourage you to try to get them these days, because after doing this review, I'm thinking that I am already getting old and really on my third part of my career. But let's go back to the contents. Really, those 4 references came from an Israeli, Shalom Horvitz, that in some way collaborated in this BAR grant with another Israeli working in Texas A&M, Dr. Talpas. And from there, they start developing all these ideas that are the basics of all the models that have been used later on in poultry. And you see, I try to highlight this long sentence that I don't know if you will be able to see, but probably when you get the slides, you will read it. And you will see that the models were very few, only evaluated energy and amino acids, but they are the basis for every single level that we use in poultry nutrition in every single table. The only thing is that at that time, 1994, we were before the Windows, so we were in DOS, and this never went to be a model truly. They were transformed in tables. So people think that the information that we have and still they use as nutrition, it comes all from science, and many poultry nutritionists still believe that empirical data is better than modeling data. But in fact, the empirical data in these past 40 years, or since 30 years, since 1994, the only thing that has been proven is that the models were not too bad. And we summarized this in an event that we had 10 years ago in Brazil. And we create the second or third book that is related with nutritional modeling in pigs and poultry. And many of people that are here attended that meeting. And at that moment, I did a summary of the models that were still in use or have been developed with success in poultry nutrition. And I will discuss some of them. After that, many others have been added. And you see here a list of all the models that still you can find. Many of them, they were originally given in those old disks, but now we extracted some of those values. So some of those really have value. At the end, there are only a few that are being commercialized and actually used on our free access. And as you see, there is a word that repeats it in all the species, that is ASAS-NANP. It's from UNESCO, Universidad Estadual Paulista. I am trying to make a translation, State University of São Paulo, and there is a group there that developed a series of models, and is the only strongest one that is public and open to the general industry. And then the NRC will be using this Brazilian model. And for those that are from the US, to avoid the American word, then it's important to think that still all the poultry modeling has come outside of the United States. So we need to try to improve that, since this is the National Animal Nutrition Program, that we try to follow these steps and try to, hopefully, you guys that are already involved in modeling, include that on your projects, because there is a lot of things to do still. However, great part of the development of the poultry nutritional models have come from the industry. Many companies have seen this as a great tool for service and to guide their clients. So there are many companies that include this in economical models or in the decision-making models. So you see big, large names there like SIP. Well, the SIP has a little model that helps the poultry companies. It's customized, but it helps the poultry companies to understand weights and understand feed intakes and feed conversions and some nutrient utilization, especially energy or the caloric conversion, that is one of the standard parameters for benchmarking nowadays. So I want to point out, and here in this picture in Brazil, we have pretty much everybody that has ever worked with poultry modeling and doing some of that. And we, of course, we don't have the time to talk about or recognize the work that they have done through many years. I'm going to focus in mainly three people here. That is Dr. Craig Cohn. Actually, I'm not going to touch more on that side because he has been working mainly on productive energy that is similar to the net energy, but it's a concept in poultry that is a little bit different because poultry has a strong utilization of protein and amino acids, and consequently we don't, or at least he doesn't call it, he and many people since the 60s doesn't call it net energy, it's called productive energy. And I'm not going to talk that because it will require more. It's actually going to another area of nutrition, and I'm not going to have time for that. But Dr. Nilva Sakomura is the responsible for this ASAS-NANP model, and I chat with her on WhatsApp yesterday evening, and I was telling her I will make a little recognition of your work, because that will be the NRC, and even that that will be announced and explained later in other meetings, because the NRC for poultry is not ready. I will try to show you because it's basically a summary of what other people like Dr. Rob Gauss, Colin Fisher, and Dr. Jerry Emmons developed many years ago. And I also will discuss and show some of their models. So with that, we have finished the first part. Now we are going to have the description of these models and how it works. As many of you are modelers, I would like to check the general ideas or fundamental concepts that follow these models. They are not as detailed and mechanistic as many that I see with ruminants or even with swine. We basically have a series of the differential equations that are able to describe the growth of the animal, the body mass, the composition, the chemical composition of the animal, and with allometric equations, it's possible to estimate the parts on the body and be able to help that with the planning in the processing plant. And the models are able to include the effects of the environment, temperature, humidity, relative humidity or air velocity, effective temperature that is called. And a few have entered a little bit on the light side, lighting in general. And what I mean is, and also the health status, the impact of some diseases, not all of them, and how that affects the growth and it causes a restriction to the potential growth of the animal. And all basically are based on the great genetic potential that poultry has, and from there, how it reduces that speed. To get that data, mainly factorial methods have been used. So it means a lot of composition and factorial experiments that try to determine the main factors. And later they use either linear or nonlinear equations to describe that across the age of the life of the animal. And for every age, there is an allometry equation that lets you know a little description of the factors. And the most common mathematical function has been the Gompers to describe growth. However, as you know, Gompers requires that you have an inflection point. And poultry doesn't get to the inflection point, but because, as you know, economically, that means the point where they stop growing and when you start losing money. And one important concept here in poultry is that in order that they advance, they need to be, as the first speaker, the first speaker mentioned the accuracy and the precision. And she mentioned half pound. In poultry, we need to work in grams. 50 grams in poultry means millions of dollars for companies. So the precision has to be higher, and consequently, the Gompers equation not always really reflects that precision. It's good to describe some biological aspects, but sometimes, especially because of lack of inflation, other equations have been better in that case, but we don't have it in the models yet. So I'm going to describe the first complete model that is done by Dr. Emmons, Fischer, and Gauss, and it's called EFG. And basically, it has a model based on Gompers curve with a maximum genetic potential. That's that body composition divided in protein, lipid, and water, and relations in between those three. Try to show the feeding program that you have and the factors that affect them. Even some factors include, for example, the pellet quality or many others. And it simulates this growth, the life performance, so it's able to give the body weight, the great growth rate, and also the feed intake, calculate amino acids, impact, especially on feed intake. The main issue with poultry is that every year we are gaining in growth rate. In the last 3-5 years has reduced a little bit, but the gain was so fast that actually it also affects feed intake. So you create a model this year, in 2 or 3 years, maybe that prediction of feed intake is not as good. And that is kind of the critical issue to improve. And there are many other approaches that have gone from just energy or amino acid requirement or levels needed for certain growth. So the broilers always overeat. They don't need only to grow. They actually, by genetic selection, their regulation of feed intake is not as good. And also these models require this part of the economical analysis because they always have an optimizer. is not only to describe it, but it's very important to determine optimums. And the optimums, as you know, in economics are way narrow than just the biological part. And most chickens are not sold as a bird. They are fractioned in different parts and even the bone, and that muscle and all that part is actually presented in that way. We are also, like many of you, are also involved in the environment, the importance of the sustainability. So most of these models also include the impact on nitrogen and phosphorus excretion. Is coming, minerals are coming, and I thought that Marie-Pierre will be here, but I don't see her. So we also need to recognize that is one of the first persons, the first people in a whole group trying to work on mineral utilization, and phosphorus also is getting importance on that way. And there are models in Europe, like the Moldavi, I think that is from Israel, that had also shown on emissions. In this case, we are going to talk about just nitrogen excretion. And talking about the feed intake, the group with Dr. Sakomura and Dr. Gauss, that you see them always, they work together. They have seen that one of the ways to regulate that, or not regulate, but actually describe that overconsumption of broilers is to include the water holding capacity of the feed. That will be the limitation that the animal has to stop eating, and that will be better than the energy or the other nutrients as a predictor of feed intake. And of course, also there are parameters of temperature that can be affected. So with the different differential equations, you can actually have a little better prediction of feed intake. However, I can tell you, one of the important things that I see in modeling, that especially to put it on the industry, is to do applications, and sometimes it fails. So we still need a lot to learn on a prediction of feed intake on that. And on the other side, on the compares, just to keep an idea, so we have the equation. There are different ways to see the equation. So this is the classical form, or the first derivative, I think that is, and this will be the second, that is where actually you go to coefficients where you don't have to go to the maturity weight. So in this form, you can work with broilers. In this one, you need maturity. So it means that you will need to raise them until at least 19 weeks. And that doesn't happen commonly with broilers. You get the data with breeders, but breeders are really very highly feed restricted, and their growth is totally different. So really, most of the time to do good modeling with broilers, you need to use this form that help you with data that is below the 49 days, 42 days even. However, they fail when it's below 35 days. And as I mentioned, there are allometric equations. All these models have been years of research. So there are many publications, and I'm using those just from the group of NESP and also with Dr. Gauss. But many other researchers have shown how to do this. They just updated and added details, as for example, how the animal use the protein in the different muscles, because that also changes. I believe in almost all the species, there is a difference on the utilization depending on the parts of the animal. So the other models only used to break it in parts. They also have the metabolic part that is, it changes, and there is fat deposition, for example, in birds, mainly on the skin or on the abdominal part, and less in breast muscle. So it's more effective for, let's say, amino acids in the breast muscle. And when you go to the application and how it's presented to the users, and this will be presented for the NRC people, and I don't know, I am looking the faces here, but I don't recognize anybody from poultry. Anybody else here working in poultry? Not every, one person. Yeah, you work in poultry, that's right. And nobody else. Well, anyway, people will see this online. So for those that will work in poultry, this pretty much is the way that it will be presented, but don't get afraid. One of the limitations when people that are not in modeling and don't understand these terms is, what is the maturity protein? What is the protein deposition ratio? This terminology is a little bit difficult because it's not the daily life of people. So this has been facilitated giving these values. So you actually select the genetic line. In many cases, you don't have to. Genetic lines, everybody knows. Well, and some of you that work in poultry. Poultry is very well organized in the sense of genetics. We only have 3 companies in the world, and they have a specific genetic lines that have a code, and we have the manuals, we have the description of what they need, how they should grow, what is the expected body weight, of course, with a large variation depending on the management. So with that, you can describe the bird pretty much in some way. And other way that the EFG does it is pretty much you enter the values, and actually they come by default. They come already, and they need to update it as the genetic lines keep progressing in performance. So this maturity fat content or rate of maturity, and especially on all the models, we have 2 compartments mainly: the whole body without feathers or feather-free body weight, and empty body weight. So taking that part of the gut contents, and also the feathers. So in the feathers, we have the description of the feathers, you know, is more protein. It still has all other nutrients, but in way lower amounts. And also you have a way to calibrate and actually see how your calibration looks in the sense. And so these parameters are all well described in different tables, and normally the software comes with a table where you can understand for every genetic line. These are the 2 main that could be 85% of the whole market in the whole world. You can have the parameters that describe all these aspects of the model that you need to include. And then it comes the factors that affect the growth, and there are many that since there are many, and it's difficult to know if it was a health challenge or an environmental challenge or just bad management or whatever, then you can restrict the growth from the maximum growth graphically. Actually, you can put the cursor here, and I will show up a little hand that will reduce what percentage during the life you don't see the growth that is expected as a maximal genetic potential. So it tells you, because it changes if it is early in life or it's late in life. So they have created this, and both models have that. And for the growth limitations, for example, you see that temperature is one of the more limitants. Heat stress is one of the biggest issues, and I don't know why the cursor is not working here. It's there. Okay, so then there is an effect of the temperature, but also that affects the fat and protein deposition. So it shows that, and there are studies that include some coefficients that, depending on the disease, they will affect. So there are some options if it is a bacterial challenge, a viral challenge, or a coccidial challenge as well. And you see here another example where we see the reduction and the coefficient that is changing that genetic potential. Also, the calculations are done for an individual animal, but that doesn't work for the population. So the software contains a way that in many ways will correct the population. And in poultry, we always think about flocks. We don't work as you in ruminants or even in pigs. Sometimes you work with a specific individuals in the herd, and here is the whole flocks, 10,000, 20,000, 100,000 birds. So in order to do that, then there are parameters like, for example, mortality. One that happens, and then it will make the corrections and simulate several birds and include that as a factor of correction to give the average value for the flock. And I want to emphasize between the collaboration of the University of Nespi in Brazil and the University of Laval and Maryland, Dr. Rosalina Angel, another Colombian that likes modeling, and I have worked many years with calcium and phosphorus. Then they developed this model that is already in use and part of the UNESP model that is able to, in some way, calculate the utilization of calcium and phosphorus for the levels of calcium and phosphorus, and also for the effect of phytase, that is the most common enzyme, exogenous enzyme applied to all poultry feed around the world. And at this moment only shows the effects directly on the phosphorus. It doesn't evaluate the extra phosphoric effect when you have high levels of phytase, but it's going there. and also the other impacts in other nutrients and minerals is not included. It's mainly, as you see here, is impacts on the compartments of calcium, phosphorus, and other miscellaneous effects that it can have on there. Again, the economical part, there is on inputs on the cost and also on the outputs on the different costs, so you can include it. And here, I believe there are in reals, but they or in is the South African currency, but you can change to any part of the world, changing that currency on the installation in the software, so you can do that. The models also help you to understand what is the exactly the time. We are synchronized here, but like Dr. said about the importance of synchronization in timing. So we are right on time, and then the model help you to understand what is the most limited amino acid, which is important for the balance of the diets. It helps you also with, to know when the genetic potential will be met or not, so that gives you an idea how to improve diets, and in some way automatically does it when you have the optimization. And later when you want to compare results, you can do it in a table form or in a graphical form in many different ways, and for the different phases parts of the that you had selected. And on the live performance, of course, give you all the parameters for the flock, live weight, weight gain, feed intake. And one important thing is in the utilization of these models, it's important to take in consideration the variation that you are going to have in the different flocks. So you get for an average value, but if you want to have real good factors, you need to have other simulations to show what are the streams that you will see in a house or in farms, in between farms. So you need to not only do one simulation, you need to do several, changing those factors that are key, like the temperature, the stocking density, the mortality that could be different. Those factors are influencing those final results. And some people don't do that. Some people want to have in one simulation everything, and it's impossible, as you can imagine, because every parameter has a role. And also, it will give you the growth of the breast, and this is good for planning on the cuts and to meet target goals in the processing plants. And the economical part, it tells you how it's changing, the economics in general through the life of the animal, so people can guide better harvesting times and so forth. And the optimizations can come in many different ways. So you can do it just for feed conversion. You can do it to minimize nitrogen. You can do it to maximize net income from or revenue in general from the conditions that you have. Now I'm going to mention a little bit about other models, mainly empirical, obtained with experiments. And this is what Eviagen, one of the largest genetic group in the world, has developed to show especially the economical impact of changing energy and nitrogen, well, amino acids actually, in their diets. And so it's basically made to estimate economical optimums, and they calculate the amino acids that you need, and also optimize the responses according to that. So they have a response surface regression, and with that, they are able to know for their lines and even for other lines, they are able to estimate pretty much what are the responses at different points on life. So then they can tell them what are the optimal levels of amino acids or energy that will maximize their margins. So they go to try to margin of income. So they want to go more to the economical side, but of course they are able to guide the nutritionists on their part. But this is not a model that is available to the public. The clients don't receive it. They get it as a consultant part. So they meet with each client in every part of the world, and their nutritional director in the area go through that. I want to emphasize one that I work a lot, but it's not anymore available. Very empirical, obtained with tons of data, and that is the reason to introduce the last part of my talk, is that these are not done with experiments. These are not done with 10,000 numbers. They are done with millions of numbers of integrations So this company, Novus, actually created a company called OmniPro, and all of the people that are working the previous one that I just showed you, just that they move from company to company, but it's the same people, very few people. I can count them with my fingers here, and they are the same people. Most of them are retiring. The one that developed this one and helped to develop the previous one in Eviagen just retired a month ago. And then they used tons of data and created a model that had very good accuracy and precision, and I will show you. It was available online, and their clients could simulate diets. We did an evaluation years ago showing between empirical model and also one of these more mechanistic models that they are on the same way. The origin of the data is different, and they are more precise one than the other, and these are pretty much the results. And the results show you have an R-square of 0.96 between observed and predicted, relatively good for body weight. It fails on feed conversion basically because it fails a lot. There is a lot of variability on feed intake. Actually, there is sometimes not even correlation with the data on feed intake, but then the mean square prediction error, and I got this from Luis Tedeschi many years ago when he published this, how to evaluate models. And when you go to the broiler model, the more mechanistic, of course, is more precise, 0.99 precision on the body weight, but still the mean square prediction error is higher. So that means that potentially there are more chances for improvement there, even that it's feeding well the data, but there is something that is not well understood there. And when we get the OmniPro on the other side is very bad on feed conversion, because of course, when you don't have an explanation of the causes of that changes in feed intake, then the feed conversion also is affected. The more mechanistic in feed conversion is a little better on that, but there is still higher error, a lot of ways to explain better that. Is that correctly? I get afraid of talking about modelers that I'm not saying the things right. So the final part is this proposal that we are in the way of analytics and we have big data to use. And there is a lot of data in poultry, sensors getting tons of data every single day in every farm. But how we integrate this information, and there is a nice proposal from the group of Dr. Ellis for maybe 4 or 5 years. I have seen these publications where they show the potentials and the different methodologies that you have. Here you have a different type of modeling, and it's not new. You see that in 1981, 1988, there were many different proposals to do comportamental models that use part of commercial data. And there were system dynamics that are also used and that help to integrate that data. So the proposals are not new. There are commercial companies that do optimization, and they have done great job in Brazil. You see some of these are in Portuguese that use just linear programming to estimate body weights and also reduce variability. And in that way, they are able to target body weights. And this has been used in the Brazilian industry for more than 36 years. And many other companies in the United States, Colombia, Spain, and Canada, they produce some type of models that use data from sensors in different parts of the whole supply chain to integrate that and help prediction. Mainly body weights, mainly feed intakes or amount to plan feed intake. And there is a nice publication, probably the only one that explains how they had done that. And they did this in 1990. So we're talking about 33 years. So the integration of big data in poultry is old. And some people have figured out how to do it without machine learning or without artificial neural networks. With simple methods have generated millions of dollars, and they have able to control in the industry and using decision making how to improve feed conversion, how to get targets and be close to the production targets. But now we have more and more data, and they are multidimensional. So we have now videos, we have that data from many feed plants, processing plants, and many other things. So there is more integration to do. We have data that from the hatcheries, and even the chickens are weighed every single day, and they are improving or between machine vision and these electronic scales. They are improving on that information, but the companies don't have the people to use it. And really, most of the scientists and engineers still are overwhelmed with what to do. The houses are getting full of sensors. In America, we have many sensors that we don't even use. They are even disinstalled because, like sensors for water, they have tons of data on water, and they never look at it because they never were able to integrate it on what to do with that data. And in Europe, they have machine vision, and the farmers know how to use that without entering in the house. They have it. Here, we don't have that. We don't have sensor for ammonia because we have a lot of recycling leaders, so a lot of ammonia, so that damage the sensors. But that's important and a lot of room for improvement. But I can tell you, in China, they are investing a lot on this. I took this picture in a data center that they have with large company that actually they get very rich, and they went to copper to produce copper, and they are richer. They even show you the gold that they can mine. So but their core and their heart of the owner is with chickens. So they keep investing in sensors and in data centers where they do modeling in many different ways. I went to give a talk, but I think that they knew every single word that I told them because they showed me all the papers that I tried to use. They had it highlighted in detail and all that. I don't understand everything that they said, but I can tell you that they are very advanced on applying that. So my last slide, to be on time really, is the future perspectives. And one of the things is, of course, we have done many things in energy and amino acids, but very little in mineral utilization and vitamin impacts that really ended up affecting metabolism. We also have to improve on lighting, on feed additives. Feed additives are both antibiotics and the alternatives, and all that affects many factors and the efficiency, and they are key for this. And also the litter conditions, a lot of differences in between flocks that use recycled litter or new litter. And we need to integrate this big data, machine learning, artificial intelligence with the mechanistic models. And in some way, the part of the mechanistic models will need to be replaced because simple differential equations are not able to reflect all the possible interactions. And the biggest challenge that is part of the bigger, I think that I have expressed this, the biggest challenge is that we need more people trained in modeling to use this, because this will be the first time in an NRC release or publication for poultry that includes models. And once that we have it, then more people will have to use models. And nutritionists, and in no university or poultry science department or monogastric class is teach how to use poultry models that are different than the swine or the ruminant models. So we need to work on that. And as a conclusion, there are many mathematical models in poultry. The current accuracy is acceptable. It needs to be improved, but there is very low utilization, and that is a big issue. Most models for broilers depend on accurate descriptions of the growth, of the mass and chemical components, and we need to add more characteristics. Big data can be integrated on those to make the modeling more successful. And there is a lack of academic training in modeling, and that is limiting the development in poultry nutrition. And that is one of the objectives of the National Animal Nutrition Program, to improve on that training. Thanks for your attention.